Guys, welcome back. In my previous video, I showed you the first example for a shortcut method which involves ax plus b, which was more like a power rule type of an example. Guys, now there's three more and I'm going to quickly illustrate those with some examples. The second one, we already covered number one in the previous video. The second one is something which looks like an inverse function involving ax plus b. So it's something like this, ax plus b raised to the power negative 1. And if we are trying to find the integral of this quantity which looks like an inverse function, guys, again we have to remind ourselves what is the integral of x to the power negative 1, or what is the inverse of an inverse function. And we already know that the integral of an inverse function is the natural log of x. So in this case it's going to be the natural logarithm of ax plus b. Of course there's a plus c, but then you already know that we have to include one more thing or one more step here, which is we have to divide this by you can just simply think of that as this constant or the coefficient of x, which is an a, or you can also think of that as the derivative of that piece inside the parentheses. So we have to divide this by a. This becomes the formula or the shortcut to evaluate the integrals of the inverse functions which involve types like ax plus b. Guys, this is number two. Then let us quickly look at an example on this. So an example on this, let us say I have a function, let's say 2x minus 5 raised to the power negative 1, and we want to find the integral of this. Again, guys, you can also do it using the substitution method. It's more steps, but it can still be done. You would still get the same answer, okay? But just using the shortcut, it would simply be the natural log of 2x minus 5 plus c, and you got to divide this by the, whether you think of this as a coefficient of x or the derivative of that inner piece, which is the derivative of the parentheses, the piece inside the parentheses, so it is just positive 2, so that would be the integral. Okay, and you can get the same thing by using the substitution method if you want to use the substitution on this. Guys, then number 3, we have an integral of an exponential of the form e to the power ax plus b. Again, this can be dealt similar to what you would do with then integral of an exponential function of the form e to the power x, and we know that both the derivative and the integral of an exponential function of the form e to the x is just the e to the x, which is what makes these exponential functions of that form very special and interesting to work with. So in this case, it is almost going to be the same, except for you have to divide it by the coefficient of x or the derivative of that exponent here or that inner piece, okay? So it's going to be e to the power ax plus b. Guys, as I already said, like, it's not too difficult to remember these shortcuts. So that's why I'm sharing these shortcuts with you so that you know them. And then if you're trying, if you see an example like this on your homework or a test, then you can quickly use the shortcut and just be done with it. And then there's a plus c. Again, we can look at an example here. Let us say we want to do the integral of e to the power, let's say I have negative 3x minus 5 dx, and then using this the shortcut method, it is simply going to be the same exponential function, negative 3x minus 5. All I have to do is I have to divide this by the coefficient of x, which is negative 3, or which is also, you can also think of that as the derivative of this function, right? So just divide by negative 3 plus c. Okay. So guys, this is 2 and 3. I also want to show you number 4. So I think I'm going to get rid of number 2 here, and I will show you number 4 right here, so that we have all of them in just one video. So what I'm going to do is I'll get rid of this. Quickly want to show you number 4, and then after that we're going to move into the world of definite integrals. Okay. And then, so guys, number 4 is again an exponential function of the form, instead of e, we're using a c, which can be a positive or any negative number. And then of course we have a raised to the power ax plus b. Guys, you can already see that all of these 4 types that we are discussing here, where we can use the shortcut method, all involve ax plus b, okay? So they're only going to work for this form. And then of course there's a dx. So guys, to simplify or evaluate this integral, again, it is somewhat similar to evaluating something of the form c to the power x. So you just write the same, it is the same function, but you have to divide it by the ln of c, and then of course there's this constant c. Guys, this constant c or this c could be same or different, it does not really matter here. And then you still have to do one last thing, which is you have to also divide this by the coefficient of x, or you can think of that also as the derivative of that inner piece, which is obviously a here. And that is the shortcut formula for evaluating integrals of this type. As an example, let us say we have, let's say I have 2 to the power, let's say I have negative 3x plus 4 dx. So if I want to evaluate this integral using a shortcut method, of course we can still do it probably with the substitution method, but the shortcut method is easier and quicker. So it's going to be 2 to the power negative 3x plus 4 divided by, of course they have to be divided by a, which in this case is negative 3, and then there is times ln of cos c, which in this case is positive 2, and then there's a plus c. This is the value for this integral. So guys, we covered 4 types for shortcuts. There could be few more, like involving a radical of something of ax plus b form. Guys, it is similar to one of these types. You can, like, it will classify into one of these types. So these are the 4 types. Very simple. I just wanted to share it with you. So practice some more examples based on this, and then I will see you in the next video with an idea about the definite integrals and examples involving definite integrals. Okay, till then guys, take care. I will see you in the next video.